Hello everyone and welcome. In my talk today, we're going to visit the El Angel Ecological Reserve in Ecuador to see Espeletia pycnophylla growing in profusion. And for many years, I'd wanted to see these remarkable alpines growing in their native habitat, so I was thrilled when the opportunity arose. Now, the paramos are high-altitude grasslands. They lie between the tree line and the snow line at altitudes of between 3,500 and over 4,000 meters in the Andes of South America, all the way from Colombia in the north, south to Ecuador and Peru. In the El Angel Reserve, it's cold, even though it's only 80 kilometers from the equator. In summer, the temperatures can reach 18 degrees, but in winter, the daytime temperature rarely rises above zero. And this means that organic matter doesn't decompose. It accumulates, and then the moist climate turns it into a giant natural sponge. Now, a good path and boardwalk has been constructed through the El Angel Reserve, and it runs for about 2 kilometers. The vegetation on either side is mainly composed of giant rosette plants like the Espeletias, but you do get some smaller plants and some shrubs and grasses as well. And giant rosette plants are an iconic feature of these tropical alpine ecosystems. Plants in the paramo have adapted to grow in harsh, cold conditions. And one method is to grow in rosettes, so that the wind and the extremes of temperature are less able to chill the center of the plant. Another characteristic of plants in the paramo is pubescence, and indeed the leaves, the stems, and the calyces of Espeletia pycnophylla are covered in dense white hairs, which again affords protection not only against the extremes of temperature, but intense radiation, which occurs particularly in the dry season when plants are subjected to quite strong heating of their leaves. Espeletias are characterized by having a thick, unbranched trunk, up to about 4 meters in height, and with a continuously growing rosette of large, succulent, hairy leaves on the top, arranged in a dense spiral pattern. And in the majority of rosettes, the old dead leaves remain attached to the stem, forming a thick covering around it, protecting and stabilizing the rosette against the diurnal temperature variation. And the leaves remain on the plants, enclosing the stem, and new roots develop along the length of the stem and all the way to the ground. And this just shows you a close-up of the rosettes, and you can see the hairs on both sides of the leaves, so they glisten almost white in the sunshine. Now, the Espeletias take several years, of course, to reach flowering size, and then they produce their very large inflorescences. Many species are monocarpic, and they die after producing seed. But Espeletias are quite valuable. You could see they extend for a considerable distance, and they contribute to the environment by capturing water vapor from passing clouds in their spongy trunks, and then they release it through the roots into the soil. And as such, they actually help to create vast high-altitude subterranean water deposits, which may, on occasion, even form small lakes and maybe streams and little rivers. Now, the boardwalk, I said it went on for about 2 kilometers. You wind over some small hills and eventually reach this point, which is about halfway round, when you're looking over the lake, actually towards the Colombian border. That is Colombia on the other side of the lake. And there were other plants beside the boardwalk in this area. On the left, you've got a ribes species, a species of flowering currant. The top center is Pinguicula calyptrata. This little Pinguicula is found all the way up to central Colombia, in sphagnum bogs, mossy seepages, and damp stream banks at altitudes of above 3,500 meters. And the flowers are purplish or pale violet with a blue or white throat. The leaves are basically elliptical in shape, they're yellow-green, and they're incurving, as you see in the image. Below that, you've got a picture of Viola glandulifera, a very pretty little viola, with yellow flowers. The backs of the corolla tube are purplish, and then the leaves are slightly crenate. On the right, you've got a member of the Asteraceae, a nice purple groundsel with ray florets, and then these purple bracts enclosing the flower. But then as you, having gone the full length, walked the full length of the lake, you start to climb again up a path over a small hill back to the start point. The reason that the paramos of Colombia and northern Ecuador are so cold and humid throughout the year is because, of course, the air masses that rise over the mountains precipitate moisture in the form of rain, fog, and clouds. But amounts can vary quite widely from 500 millimeters a year to 3,000 millimeters a year. It depends on the location. But generally speaking, in the south of Ecuador and Peru, precipitation is generally less and the climate is drier. The temperature can fluctuate quite widely, and this oscillation often results in a daily freeze-thaw cycle. So in short, of course, we're beginning to see the paramo atmosphere is quite unusual and extreme, with considerable daily variations in temperature, frequent frosts, and high levels of UV radiation because of the altitude. And we reached a little viewpoint, the Mirador. You can see the altitude we're at. And of course, within the Paramo ecoregion, there's quite a high degree of local endemism, and because the plants and the animals have adapted to the cold, dry conditions of these high areas and often isolated peaks. And this is just a final view of the lake with still Espeletias. You can see them into the distance. The soil types within the paramos vary widely depending on the underlying bedrock and the degree to which organic matter has built up over time. That said, most of the soils are young with a relatively low pH and little in the way of nutrients, so the plants that you see here are adapted to almost acid conditions. And on the left, you've got Maclania rupestris, which here is a terrestrial shrub growing up to 2 meters. But oddly, it can also be an epiphytic shrub and scramble through other shrubs and small trees. It has edible fruit, and the leaves are oval and alternate. The flowers, rather prettily, are in clusters of bottle-shaped blooms with little white or cream tips. In the center is a plant of Eryngium humile, and this makes rosettes of glossy, leathery, crenate leaves. The flower heads are often solitary, up to about 15 centimeters in height, and it's widespread throughout the Andes, all the way from Venezuela to Peru. On the right was another of the purple-flowered gentians, and it's very much a native of this paramo grassland. Now, in total, the paramos cover an area of over 3 million hectares, with Ecuador having the highest percentage of paramo of any country. It comprises 7% of its land area and about 47% of the world's paramo landscape. Millions of years ago, when the climate was cooler, these regions of paramo formed a continuous area. Now they exist as islands surrounded by a sea of cloud forest. That's a final close-up of the Espeletias, and my last image is going to say goodbye with a farewell view into which a puya has actually crept as well. So this has brought me to the end of my talk, and I hope you've enjoyed seeing something of this very remarkable and unusual alpine plant.